We end tonight with the clearest pictures yet of Neptune, the most distant planet in our solar system. We're looking at Neptune's orbit, and it's not following Newton's laws, and this is hard. The closest images ever taken of Neptune revealed a shocking discovery. For ages, Neptune has captivated scientists and dreamers with its mysterious charm, hidden behind a veil of secrecy and passion. But because of tireless efforts in scientific discovery, scientists are on the verge of a remarkable breakthrough, the clearest pictures ever taken of this faraway, icy giant. These images provide a peek into Neptune's stormy atmosphere, revealing a surprising finding that will change how people see the outer edges of the solar system forever. In August of 1977, Voyager 2 embarked on an extraordinary journey through our solar system, venturing where no spacecraft had gone before. It set out to explore the outer reaches of the celestial neighborhood, marking a remarkable moment in space exploration. After a 12-year journey, Voyager 2 reached Neptune in 1989. As it approached the distant ice giant, it captured breathtaking footage that unveiled a majestic world shrouded in stirring bands of azure clouds. Imagine witnessing this distant sibling of Jupiter adorned in shades of mesmerizing blue. Among Neptune's mysterious features, Voyager 2 detected a colossal storm raging across its atmosphere, resembling a massive slate-colored uproar. Additionally, the spacecraft discovered 4 mysterious rings encircling the planet along with 6 previously unknown moons, adding to the allure of this distant realm. Despite its epic voyage spanning 7.1 billion kilometers, Voyager 2's encounter with Neptune was fleeting, lasting only a few fleeting hours. However, this brief rendezvous provided humanity with unprecedented views of the distant ice giant, capturing the essence of Neptune's captivating beauty. When considering Neptune, many of us think of the iconic image memorialized by Voyager 2, a portrait showcasing the planet's towering white clouds and turbulent storms, all bathed in a famous yet mistaken hue of blue. In reality, Neptune's true color is a softer, lighter shade of greenish blue, a subtle detail often overlooked in the grandeur of space exploration. When venturing online in search of more snapshots of Neptune, people quickly notice a scarcity of images. Despite Voyager 2's impressive feat of flying within a hair's breadth of just 4,950 kilometers from Neptune's surface, the number of available photos remains surprisingly low. What makes Neptune so elusive to capture on camera? Imagine, Neptune resides a staggering 30 times farther from the Sun than people do on Earth. This vast distance means that it receives only a fraction of the sunlight that our planet enjoys. Consequently, when Voyager 2 finally caught up with Neptune after its gravity-assisted journey past other outer planets, it was hurtling through space at an astonishing speed of 27 kilometers per second. While Neptune may seem like a distant speck in the universe, its allure lies in its perplexing blue hue and mysterious atmosphere. But capturing these mesmerizing details proved to be quite the challenge for Voyager 2. With Neptune receiving only a mere 0.1% of the sunlight that reaches Earth, the spacecraft struggled to snap clear, non-blurry photos amidst the dimly lit expanse. Voyager 2's ingenuity knew no bounds. By deftly working its thrusters to swing as it soared past and employing extended exposure techniques, the spacecraft managed to capture and transmit back to Earth some of the closest and most mesmerizing images ever taken of Neptune. Just a couple of hours before Voyager 2 zoomed past Neptune, it captured an incredibly detailed picture. In it, scientists got a close-up view of some interesting features high up in the planet's atmosphere, long, wispy clouds that resemble the cirrus clouds people see on Earth. They're not made of water vapor like Earth's clouds. These clouds are crafted from frozen methane, giving them a surreal appearance. Imagine these cloud formations stretching for thousands of kilometers, running parallel to Neptune's equator. They're not just some puny clouds, either.
Each streak measures between 50 to 200 kilometers wide. These clouds are so high up that they cast shadows onto the hazy layer about 50 kilometers below. What's even more mind-blowing is that even though Voyager 2 had already checked out all the other gas giants before Neptune, it wasn't until Neptune that people got their first ever glimpse of these elusive cloud shadows. As evidenced by the grainy image captured, these high-altitude clouds are like fleeting guests in Neptune's atmosphere, always on the move and changing shape. Recent observations from the Hubble Space Telescope revealed that these clouds can form and disappear in the blink of an eye, showcasing the dynamic nature of Neptune's weather patterns. When this picture was captured, strong winds would have been swirling around the ice giant, some blowing as fast as 2,100 kilometers per hour. That's 3 times quicker than winds on Jupiter and almost 9 times speedier than those on Earth. Voyager 2 revealed that Neptune experiences some of the most extreme weather in the solar system, and when the spacecraft flew by, it encountered a striking example of this event. This image is the closest view ever captured of the once furious storm known as the Great Dark Spot, a large oval-shaped cyclone resembling Jupiter's Great Red Spot. This immense weather system was roughly the size of the entire Earth. What's fascinating about this image is that the center of the storm appears to be relatively clear of clouds, forming a vast dark void slicing through Neptune's atmosphere. Neptune is an incredible ice giant, about 4 times wider than Earth. Its radius is around 15,300 miles, and it has an enormous volume of 15 trillion cubic miles. To put that in perspective, Neptune is 58 times larger in volume than Earth. This fascinating planet is mostly made of water, methane, and ammonia. Unlike Earth, Neptune doesn't have a solid surface. Instead, its thick atmosphere extends deep into the planet, reaching down to a mantle made of methane and ammonia ice surrounding a rocky core. Interestingly, scientists think that Neptune might even have a super-hot ocean hidden deep inside. Despite its icy name and outer appearance, the conditions inside Neptune are anything but cold. But how can a planet sustain such an ocean when it is so far from the Sun? Sunlight takes a whopping 4 hours to reach Neptune's massive surface. Neptune is incredibly cold, with an average atmospheric temperature of -360 degrees Fahrenheit, making it one of the chilliest places in the solar system. Interestingly, most of Neptune cooled down between 2003 and 2018, though there was some warming near the South Pole from 2018 to 2020, likely due to seasonal changes in the atmosphere's chemistry. The mystery of how an ocean might form inside this icy giant remains unsolved. However, scientists have some theories. One idea is that internal heating caused by gravitational compression or interactions between Neptune and its largest moon, Triton, might play a role. Yet not all researchers agree. For instance, scientists Sloan Viktorovich and Andrew Ingle argue that the chances of oceans forming on Neptune due to its internal heat are quite slim, estimating it at only 15%. Right now, their calculations suggest that it might take 1 billion years for the probability of such an ocean to rise to 40%, assuming the giant continues to cool down over time. One interesting theory for Neptune's immense internal energy is that it might have collided with a cosmic object long ago. Neptune stands out as the only planet that radiates nearly 3 times more energy than it absorbs from the Sun. This unusual energy output might be linked to the planet's significant 28 degrees tilt on its axis, which is quite similar to Earth's tilt. This tilt means Neptune experiences seasons much like Earth does, but with a twist. Each season on Neptune lasts around 40 years. To put it in perspective, 1 Neptune year equals 165 Earth years, but a day on Neptune is just 16 hours long. This fast rotation generates extremely strong winds. Neptune's atmosphere is composed mostly of hydrogen, making up 80%, with helium accounting for 19% and a small fraction, about 1%, of other gases, including methane. The striking blue color of Neptune is a result of methane clouds in the upper atmosphere, which absorb red light and reflect blue. Methane plays a significant role in shaping the atmospheres of both Neptune and Uranus. Despite being the farthest planets from the Sun in our solar system, these ice giants still receive a significant amount of solar radiation, albeit much less intense than what inner planets like Earth receive. Neptune's vivid blue coloration has captivated astronomers for centuries, but the exact mechanisms behind its striking color continue to interest scientists. One fascinating aspect is the presence of high-altitude clouds composed primarily of methane ice crystals. These clouds scatter sunlight in a way that enhances the blue coloration, similar to how Earth's atmosphere scatters sunlight to create blue skies. Furthermore, Neptune's dynamic atmosphere exhibits a multitude of features, including massive storms and powerful winds. On the other hand, Uranus presents a different aesthetic with its muted, pale blue color. This planet's unique tilt, where its axis is nearly parallel to its orbital plane, results in extreme seasonal variations. During its long polar winters, Uranus experiences prolonged periods of darkness, hindering the formation of high-altitude methane clouds that contribute to its overall coloration. In addition to methane, both planets' atmospheres contain trace amounts of other gases, including hydrogen, helium, and ammonia. These gases, along with the intricate interplay of temperature, pressure, and atmospheric dynamics, create a complex and dynamic environment worthy of scientific exploration. Neptune holds many mysteries within its icy depths. Its intense blue coloration, derived from methane in its atmosphere, adds to its allure. But beyond its captivating hue lies a world of extremes. The storms that rage across Neptune's surface are not just any storms, they are colossal tempests, some spanning thousands of kilometers. These atmospheric disturbances, marked by dark and white patches, are the result of Neptune's rapid rotation, completing a day in just under 16 hours. This rapid spin generates intense winds that whip across the planet, reaching speeds of over 2,100 km per hour, the fastest in our solar system. While Voyager 2 provided invaluable insights into Neptune's atmosphere, much about this distant world remains unknown. Scientists are particularly interested in Neptune's internal structure, which is thought to be composed of a mix of rock, water, ammonia, and methane ice, surrounded by a thick atmosphere. The idea of an ocean beneath Neptune's icy exterior is a tantalizing one. If such an ocean exists, it would be unlike any on Earth, likely composed of a dense, high-pressure form of water, possibly mixed with ammonia and other compounds. The existence of such an ocean could have profound implications for our understanding of the potential for life in extreme environments. Despite being a frigid world, Neptune emits more heat than it receives from the Sun. This excess heat, likely from the planet's core, could be driving the dynamic weather patterns observed in its atmosphere. The Great Dark Spot, a massive storm system similar in size to Earth, is a testament to the powerful forces at work on Neptune. The spot, captured by Voyager 2, has since disappeared, highlighting the transient nature of Neptune's atmospheric phenomena. The unique conditions on Neptune, including its extreme cold, rapid winds, and dynamic atmosphere, make it a fascinating subject for scientific study. While our knowledge of Neptune has grown since the Voyager 2 flyby, much remains to be discovered. Future missions to Neptune, potentially involving orbiters or even landers, could reveal more about its composition, internal structure, and atmospheric dynamics. Neptune, a world of breathtaking beauty and profound mysteries, continues to captivate our imagination. Its brilliant blue hue, sculpted by methane in its atmosphere, offers a glimpse into the wonders of our solar system. As technology advances and our understanding deepens, Neptune beckons us to explore its icy depths and uncover the secrets it holds within its frozen heart.